when you look at a polar graph, you have the origin, which is not called the origin in polar graphing. It's called the pole, okay? So the pole is the same as the origin, but it's called the pole because it's a polar graph, kind of like the North Pole. This is the pole right here. And then when you write points in polar graphing, you start by giving the radius that you're going to go out and then the angle that you rotate. So for instance, if I wrote this, is that polar or is it XY? Is there any way to tell? No, and that is one point that's going to be problematic. Is it's very important that you understand context and you be able to tell what that point is from context. So usually when we do polar graphs, the angles will be either in radians and there'll be pi's in there and that'll help give you a little context, or the angles will be in degrees, in which case the degree symbol will be there and that will give you context. But generally you have to know what you're doing. So you have to look at the problem and see the context of the problem to know for sure if it's X, Y, or R theta. So in Cartesian coordinates, so Cartesian, it would be XY. In polar coordinates, it's R theta. Okay, and when we talk about R and theta, R is the distance from the pole. But this time it's actually a directed distance. So I need to be careful here because R can actually be negative on a polar graph, which causes lots of consternation for students. Same thing with theta, it can be negative. So when we talk about R, R is how many rings you go out. So if I had the point, let's say 3, and then 2 pi over 3. So if that was my point, then that means I go out to the third ring. So 1, 2, 3. That means my point's going to be somewhere on this ring right here. Okay, so it's on that third ring, and then we go to the angle 2 pi over 3. So I rotate from 0, 2 pi over 3. That's right here, and this graph is actually labeled, so it'd be on this line right here. And then the intersection of those two is the actual point. Generally, it makes more sense to start with the angle and then just use the distance from the pole. So I can do the ring and the angle thing and find the intersection, but usually we just say, okay, go to 2 pi over 3. It's on this line and it's 3 units out. 1, 2, 3, right there. We'll do it one more time. So when I give a point like this is the R value. This is the theta value. Okay. This tells me how far from the pole I am. And this tells me what angle I rotated. So in this case, the angle I rotated was 2 pi over 3. So I rotate around to 2 pi over 3. And then the distance away from the pole is 3. So 3 units. So that's why these are circles instead of rectangles, because really we're talking about circles of a certain radius. And if I rotate to 2 pi over 3 and go 3 units from the pole, 1, 2, 3, I get this point right here. So this would be my point. Let's say I call this point A. Then if I wanted to do another point, I could always give different coordinates for, say, point B. And that's actually what we're going to do on the next slide, is we're going to plot some different points. So as an example, we're going to plot these points. We're going to plot point A, that is 2 pi over 2. We're going to plot point B, that is 5, 330. We're going to plot point C, that is negative 3, 7 pi over 6, and then point D, that is negative 1, negative pi over 3. Okay, all of these are possible to plot on a polar graph, but the hard ones are the ones with negatives. They're the ones that are a little harder for students. We'll start with the easier one though. So for A, I'll come over here and I'll look at what I have. I have an R value of 2, so that means I'll go 2 units away from the pole. But I usually look at the angle first. So what is my rotation? So if I look at where I've rotated to pi over 2. So that would be along this line right here. Okay. And then I go 2 units away from the pole. So 1, 2. So then point A would be that point right there. So I rotate to pi over 2, whoop, and then go 2 units from the pole. Now if I go to point B, once again, I'm going to start with the angle, 330 degrees. Now I need to convert that to radians in this case. But if I think about what 330 is, it's 30 degrees short of 360. And these are actually 15-degree increments. Okay, so this graph paper, usually 15-degree increments is the way polar graphs are broken out, but some are 10, some are 30, some are, you just have to look carefully at what the increments are. But the graph paper I'm using here is 15-degree increments, and the reason I know that is because pi over 6 is 30, and this is halfway between. So then this is 15 degrees. So 330 is 30 degrees short of 360. So that would be 11 pi over 6. So I'm here. So I need to be here. And it's 5 units away from the pole. So 1, 2, 3, 4, 5. And notice I'm moving towards the angle that I rotated to. Okay, so towards the label of that angle. So then this point right here is point B. Now, point C is where it starts getting a little more interesting. Once again, I'm still going to start by seeing where is my angle. Okay, so 7 pi over 6. If I look here, there's my 7 pi over 6. And I'm going to go negative 3 units. What does that mean? Yes, that's exactly right. So instead of moving towards the angle that we have labeled, we're going to move the opposite direction, but we're still going to follow that same angle line. So just like a full 180 degree around. Okay, and so negative 3. So 1, 2, 3. So I went backwards 3 units. So when you see negative numbers, this means you're basically going backwards. Okay, and it's kind of like when you have a negative angle, you rotate the opposite direction. When you have a negative R value, you move the opposite direction. Now, when we're working with real triangles, R cannot be negative. But when we're working on a polar graph, there's no restriction on R or theta. Okay? So that would be our point C. So if we go to point D, first start with the angle. Okay? Pi over 3 is negative, but is that going to be the opposite direction from positive pi over 3? So positive pi over 3 would be like that. So negative pi over 3 means going the same angle but backwards, so rotating the opposite direction. So negative pi over 3, what you could do is you could actually convert it to a positive angle by adding 2 pi to it. So if I take negative pi over 3 and add 2 pi, which is 6 pi over 3, you get 5 pi over 3. So the positive angle equivalent is 5 pi over 3. So I'm actually pointing this way. Okay. Then I have to look at the direction that I move. And instead of going forwards, I'm going to go backwards. So I'm going to move the opposite direction. So then in this case, point D ends up being here.